In the last video, we have seen that solubility depends on the temperature. As the temperature increases, the solubility of the substance generally increases. There are some substances which will show anomalous solubility. Anomalous means the behavior which is not normal. The normal behavior of solid says that with increase in temperature, generally the solubility of solids will increase. So with decrease in temperature, it will decrease. That means the amount of solute which dissolves in 100 grams of solvent at different temperatures will be different. So here, if you are plotting a graph between the solubility and the temperature, then it is known as a solubility curve. For example, when we are plotting a graph for solubility in grams here on y-axis, solubility of the substance in grams, and on x-axis there will be temperature. So say if it is 0 degree, then here it is say 10 degree, 20 degree, 30 degree, and so on. It goes on like this, and the solubility will be here in grams on the y-axis. So if a line graph is drawn between the solubility of a substance at a given temperature, you call it as a solubility curve. For example, if you are plotting a solubility curve for potassium nitrate, it shows that with increase in temperature, the solubility goes on increasing. So by seeing this solubility curve, what all applications can be done? The first thing what we can see, say if this is the solubility curve of potassium nitrate, we can see that at 0 degree Celsius, say it is nearly 10 grams. 10 grams of KNO3 dissolves in 100 grams of water at 0 degree Celsius. Then again you see it here at 10 degree, it becomes say 15 grams. So by seeing the solubility curve, that is by seeing the line graph plotted between the solubility and temperature of a given substance, we can find out the amount of solid which will get dissolved at a particular temperature so as to make it saturated solution. Then we know that with decrease in, so first thing what we have seen that we can know how much solute is required to prepare a saturated solution, of a substance at a particular temperature. Just by seeing this graph we'll come to know. Then the second thing is, we also know that with the decrease in temperature the solubility will decrease. For example, if you have prepared the saturated solution of KNO3 at 20 degree Celsius and its solubility is say 25 grams. These are examples, I am not taking the exact values. So at 20 degrees Celsius, if you have prepared a saturated solution of potassium nitrate, then 25 grams of KNO3 remains in soluble state. Now if you are decreasing the temperature, if you are cooling the solution from say 20 degree to 10 degrees Celsius, then how much of this solid will come out in the form of crystals? Also we can see by seeing the solubility curve. For example, at 20 degrees Celsius, 25 grams of KNO3 is soluble, and if you are cooling the solution to 10 degrees Celsius, then the solubility becomes 15 grams. So how much solid will crystallize out? How much solid will crystallize out when the saturated solution is cooled? When the saturated solution is cooled. Also we can find from the solubility curve. Then say if you have the solubility curve of KNO3 and you also have the solubility curve of potassium nitrate, which is, say, this is for potassium nitrate. Now you can compare the solubilities of potassium nitrate and sodium nitrate at a given temperature. By seeing the two curves, we can compare the solubility of different substances. We can compare the solubility of different solids at the same temperature. Okay, so these are the applications of solubility curve.